Okay, so we're trying to find the roots of a quadratic equation. First of all, what are roots of a quadratic equation? X-intercept. So if we have a quadratic equation such as this would be the roots. Some people call them, there's another name for them. Some people call them solutions or zeros of a quadratic equation. Call zeros why, Josh? Your question was?
Why can you just add equals 0?
Okay, yeah. So why can we just say equals 0?
That's on the 0.
Because any point along this axis will have a y value of 0. And remember, this is a relationship between x and y if we draw it like this. So it's y equals 2x squared minus 2x plus 3. So 0 equals 2x squared. Okay, so if we go about solving this, as was mentioned, there's a number of ways we can go about finding the solution, the roots or the zeros of this. One of the ways you could go it is factorization. Any other methods that you may have used? Completing the square?
How do you get zeros from
So the answer to complete the square, like we did in the previous question, when you get something like 2 plus or minus root 3, that is exactly where it crosses the x-axis. That's exactly it. 2 places. Any other thing we could use? Quadratic formula, yeah. Any other thing we could use to find? You have it on your desk, probably some of you. Yeah, graph it. Graph it, and you can use the calculator for that if you have a calculator. Okay, so there's a bunch of ways. There are a bunch of ways you can do it. No, it's yeah, okay. Completing the square is forcing factorization into a square. Because the whole point of this is this is an irrational number, yeah. So it's very hard to pick an irrational number when you're trying to factorize it. You usually pick whole numbers or fractions at a minimum. So yes, but it's a form of factorization. Yeah. But it's not fully factorized because you're left with a bit.
Because when they're easy.
Yeah. So if you have x squared plus 5x plus 6, then you go, oh, I can factorize that. 3, 2, plus, plus, and bang, what's my zeros? If I let them both equal 0, null factor law, I get this. Yeah? Okay, good question.
But we only use completing the square when it's hard. Or like as an irrational.
You know, honestly, most of the time you only use completing the square when they ask you to. Or if they ask it for in Cert form or irrational. Because I would probably just go with this one and then quadratic formula. I think it's easier.
Yeah.
Or maybe it's not easier, but once you get used to completing the square, it is easy. But if you get something like -3 at the start of it, there's a chance for mistakes. Yeah. Okay.
They're also mainly going to come up in non-calculated.
Yes. Completing the square will only be non-calculated because you can just graph it straight away. Okay. So we go back to the question. Did anyone find the roots? Yeah. What do you think about it, Bo? Okay, so you think that this one has -6 point something, and what was the other one? -0.61. And -0.61.
No, -0.61.
Yes?
And then 1.62.
Oh, and 1.62, okay. Okay, that's, Bo thinks it has this kind of shape here. Yeah? Okay. Question. Visually, looking at this, is he right or wrong?
No.
Why is he wrong? Just looking at this, why is he wrong? Plus 3. We know this is a U-shaped curve because the A is positive. And we know it goes through the y-axis at 3. There's a contradiction there, isn't there? Because yours definitely has, it could not go through that if it's a U-shaped curve. Yeah, no matter how we draw it. Okay, so there's a problem there. What was the problem we encountered? Okay. What method did you use first before your answer?
The formula.
Okay, so let's use the quadratic formula. just in case you had forgotten how to use it. A is 2, B is -2, and C is 3. So we have a quadratic formula, which is x, or the answer will be minus b plus or minus the square root of this, 4ac all over 2a. When I calculate this, minus b is plus 2, plus minus b squared is minus 2 to b squared, minus 4 times a, which is 2, which is 3. All divided by twice a, which is 2. So it's just subbing into a formula. I get 2 plus or minus the square root of what?
-20 over 4
Ne-
-5.
-5. What? What? Hold on, whoa, whoa.
No, it's negative
That's 4, take away what?
-20.
-20. Okay, so it's 4 take away 24, which is -20.
-5 plus
Oh,
2.
okay. All right. Stop.
Sorry, yes, negative.
What's the square root of a negative number? Just type it in your calculator there. Square root -20. Just get it. Just it. What was it? Error. It's not.
Non-real answer.
Yeah. So no. This. Okay. There are no zeros. So it's very possible that your quadratic equation just sits up here. It's very possible. And can still cross the y-axis at 3. That's no problem, but it just never reaches the x-axis. That's okay. All right. How could I have tested that before I started? No, without graphing it. What part of it told me it had no roots?
So this is a trick question.
If x is 0? No. What was the part that I stopped? I put the question mark. I said, oh, we can't do that.
-20. Oh,
And-
there's a negative
And
inside.
a negative inside the square root. That tells me automatically you're not going to get an answer. You're going to get an error on your calculator. You can't get the square root of a negative number. We will find out later we can, but at the moment we can't. Not in the real world. Yes?
If we got like that question in test 5, we just say no roots.
What do we say? We say no. The answer to this is no real roots. Okay.
So
But there is a test for real roots. What is it? The test for roots. It has a special name. It is this part of the quadratic equation. B squared minus 4ac. This is a symbol. It is this symbol. It's called delta, yeah. Discriminant. It is called the discriminant. It discriminates whether an equation, a quadratic equation, has no real roots, 2 roots, or 1 repeated root. What answer do you think you get? So a negative number means it has no real roots. What answer do you think means a repeated root? 0. Why?
What's a repeated root?
Because you'll add and subtract 0. If this number is 0, we'll add and subtract 0, which is the same. So you'll just get a half, won't you? If it was 0.
Yeah.
Okay. So there's no adding and subtracting. This just sits. So a repeated root is when a quadratic just sits and touches off the x. The x-axis is a tangent. Just touches off it and goes off on its way. So this discriminant tells a lot. So if I just work out the b squared minus 4ac, square this, take away 4 times this and this, I get an answer. So if it is greater than 0, what can we say?
Real answer.
There's 2 real roots. If it is equal to 0, what was the term I used? Repeated root. 1 repeated root. And if it is less than 0 or a negative number, no real roots. Okay, so let's look at, I'll get out of the way in a second. Let's look at an example. Let's look and just, the question might read, take 1 over 3x.
Wait, what's repeated about it? You just touch the x-axis.
Mm.
Yeah,
How is the repeated bit? That's a good question. How is it repeated and not just one root? If it was just one root, so remember, roots come back from something like this. Oh, x plus 3, x minus 2, or whatever, and we multiply them back to form a quadratic. If it was just one root, it would be like that, wouldn't it? And that's a line. If I drew that from your coordinate geometry, that is just y is equal to x plus 3 if I got rid of the 0. So it has to be repeated. It's actually a perfect square. It's x plus 3 times x plus 3. That's what it looks like as if we factorize one. So an equation like this has a repeated root. It is x plus 3 twice, or x minus 3 twice. So you get the same answer out of it twice. And that's why it's repeated. That it factorizes to have the same things in the bracket, a perfect square. Okay, so a question like this is common. Determine the nature of these roots. So it's asking, are there two real ones? Are there repeated? Are there no real roots? I would go straight to b squared minus 4ac, and I'll just see what the answer is.
If the constant is a negative, wouldn't it? Wouldn't it? And what's called the a is positive. Wouldn't there always be a root then?
It depends on if it wins over the b squared or the b squared. If the a and the c make a positive number, it's going to be subtracted. Minus 4ac. So you're saying this times this, if they're both positive or both negative, is it?
No, I'm saying because since it's a negative 2, and it's below the x-axis.
Yes.
And since it's
Oh, yes.
is
You're going the
positive,
shape.
that means
Very
it's
good
go
point.
up.
Yeah, very, very logical point. Yes. If you look at that, you can probably tell that this one has, because you know it crosses at negative 2, but it has an N shape. But it could just be below it.
But then wouldn't it be a negative px?
Would it?
Wouldn't it have to be a negative px?
Oh, sorry. Yes. That's not what you're saying. Yes. So you're right. Yes, this one does have. Yes, this one does have roots. Great point.
Can there be like a negative one?
Yeah. So we had this example had a negative at the start. You could have a negative here at the end, and then you'd have to see for sure whether it crosses. Okay, this one we kind of know logically. We'll determine the nature of it very quickly. B squared is minus 4 squared. That's the minus 4. 4 times a is 3. Minus 2. Work it out. We get 16. The minus and the minus make a plus. So we get plus 24 as 4t. So positive number, you could say 2 real roots. But we already knew that. You could have determined it by a sketch and then shown that it would be illogical in any other way. Okay. Right, so that's the discriminant. That may be a new word for you. I'm just going to chop this video because they tend to be too long.